Okay, welcome to Transport in Humans. Okay, now can we look at this page that we have? So today we are going to talk about transport in humans, which will comprise of several points. I'm going to break it up into a few different segments so that it doesn't get overwhelming or lengthy. Okay, now the first one that we are going to look at will be in terms of the blood components, okay, as well as the blood types that we have. Okay. Then we will look into blood vessels themselves. Okay, some of you all have gone through it in the lower secondary part. We'll just look at it deeper into it. Now the third one, we will be looking at the heart itself. Okay, so the heart in terms of the flow of blood and also in terms of coronary heart disease. Now the last one that we'll look at is more for IP or for pure students. So for this, we'll be looking at the cardiac cycle itself to see how the heartbeat goes in terms of your loud dub sound, which is the heart rate that you hear. Okay, now let's start off with the first part. Okay, so we'll be starting off by looking at this vial of blood that we have. So I'm sure you all have gone to the hospital, most of you all, to have your blood drawn for blood testing. So what they do after getting your blood is they will actually spin the blood down at very high pressure to give you these three segments that you see. Okay, now the lowest one is of course the densest. So for density, that is the highest you have got your red blood cells. Red blood cells is produced by your bone marrow. And if you recall back the characteristics that you have learned about red blood cells in your earlier days, you will realize that it doesn't have a nucleus. So due to the lack of the nucleus, it has got a very short lifespan of 120 days only. Okay, it also contains hemoglobin, which allows it to bind to oxygen at very high affinity, which will then travel throughout your body system itself. And it being biconcave allows it to squeeze through your narrow capillaries to enter cells. So once it enters cells, it undergoes this process called respiration, which you will do at a later time in your syllabus, so you don't have to worry too much about it. Now, the second layer is very small. It comprises of your white blood cells and platelets. Okay, so most of the time it is not visible when we spin the blood down. It is only visible when there's an excessive amount of it, usually during an infection, or the body is trying to fight an infection and you just don't have the symptoms of it. Okay, two main forms of your white blood cells. The first one is your phagocytes. Okay, phagocytes are the primary defenses. So what do I mean by primary defenses is that they are the first to enter the scene in the event of any infection. Okay, so what it does is it will engulf the bacteria itself. So once it engulfs, after several times, the phagocytes themselves usually die off. Okay, so the death we normally see in terms of pus, which is the yellow color thing that we see. Okay, the second one that we have are the lymphocytes. Okay, so these are produced by your lymph nodes. So let's say you go to the doctor because you are sick. Your doctor will often check the site of your neck to see whether it is swollen. Okay, so the reason why the doctor does that is because you have got lymph nodes at those regions. Okay, so normally when you have got a secondary infection or infection that you are trying to fight, there is excessive production of antibodies. So your lymph nodes get enlarged. Okay, now the last section is also one of the most important ones, which is made up of plasma. Okay, plasma is mainly made out of water. Okay, it transports both the substances that the body requires, such as your mineral salts, okay, or it also contains your soluble vitamins, hormones, food substances. Okay, it also transports substances that your body has to remove, such as things for excretion through the kidneys. Okay, so things like urea, creatinine, etc. These are excreted by the kidneys, which is why they are called excretory products. Okay, take note of the word excretory. So they are excreted. Okay, because it is by the kidneys. Okay, carbon dioxide on the other hand will be exhaled out, which you will do under the topic respiration again. Alright, now let's move on to the next segment. Okay, so in the next page, what you have are the shapes of your white blood cells. Okay, so in terms of your shapes of your white blood cells, recall your phagocytes, remember, they ingest the bacteria, so which is why they have got this extremely lobed light nucleus. Okay, so when they ingest the foreign particle, it will then ingest in this direction and it enters into the phagocytes. Okay, so in terms of your lymphocytes, on the other hand, okay, lymphocytes, the nucleus itself is very rounded, as you can see. Okay, so what they do is they will cause this thing called agglutination. Okay, so how do they do that? So your body, your cells, including your bacterial cells, virus cells, all have these things which are called antigens. They are sticking out of it. Think of them like little markers which are unique to the body. So of course, when I have got a bacterial pathogen or bacteria that comes in with a very different signal on them, what happens is that the body knows that these are foreign, and they will then send in all these antibodies to target onto it, to bind onto it. And once it binds, it will then destroy the bacteria from inside by poking holes on it. So that will then lead to agglutination, which is like clumping together. Okay, now next, for the blood clotting process. So I'm sure we all have gotten injured or hurt or have a paper cut, a cut somewhere. Okay, so the damaged tissues produced by these injured processes will produce platelets. Okay, so platelets will then produce this enzyme called ASE. So you can see that it is an enzyme due to the ASE at the back. Okay, so thrombokinase being produced will activate my inactive prothrombin into the active form of thrombin. Okay, now this will require the mineral calcium ion. Okay, so recall earlier on when we did plasma. Okay, so when you go back to your earlier page, okay, so you have got other mineral salts being transported in your plasma. Over here, you have got calcium. Okay, so calcium is not just for building bones alone. We also need it in terms of the blood clotting process. Okay. So once thrombin is activated, it will then convert my soluble fibrinogen to insoluble fibrin threads. Okay. So insoluble fibrin threads are these mesh-like substances that you see when you have a cut. You will see like you have got this mesh thing over the injured component. Okay. So what is the purpose of this? Is to actually prevent the bacteria from entering into the body system. Okay, so when they prevent it from entering into the body systems, it will then prevent what we call a secondary infection. Okay, secondary infection means an infection that is different from the primary infection. Okay, so for example, if I have got a flu, okay, my flu, as we all know, is virus. So why do we get antibiotics from it? Okay, it's because during the process of coughing, your cells at your throat might be worn off and you have got bacteria in your mouth. So that will then can possibly lead to a bacterial infection, which is a secondary infection that is different from the primary source of the infection. Okay, so that's the same thing that we're trying to talk about here when we talk about using the mesh to prevent a secondary infection.